Part D. Transmutation is the name given to a process where one element changes into another. Explain and compare how two different types of radioactive decay can cause transmutation. Okay, so we're talking transmutation is where one element changes into another. Well, the thing that changes elements, the thing that defines an element, it's worth 4 marks. 1, 2, 3, 4. The thing that defines an element is the number of protons. So what this question is really asking is, describe two types of radioactive decay where the number of protons changes. And remember, there are 3 types of radioactive decay. There's alpha, there's beta, and there's gamma. And if we, over here in the margin, if I just put down what alpha is, so alpha is 2 protons and 2 neutrons. It's very big. Beta is an electron. Gamma, well, it's just a wave. So it's got 0, 0, so it doesn't, so if I think about the numbers of each of these, it's got a proton number of 2, atomic mass of 4, got a proton number of -1 and mass of 0. So which ones of these are going to change the number of protons? Well, it's not gamma. Gamma doesn't change anything. It's just a release of energy from that electron. So we're going to talk about 2 different types, and for each one we're going to describe, plus, and we're going to make sure that we're going to have to make sure we make a comparison there as well. Okay, so with beta, we're going to compare a bit. In fact, comparison might come down here. So we're going to talk about alpha first. So alpha, let's just say what alpha is first. Alpha contains 2 protons and 2 neutrons. 2 neutrons. Okay, so when it happens, alpha decay, when it happens, proton number drops by 2 and atomic mass drops by 4. Okay, so I've only done that as 2 bullet points there. I might move that bullet point up there actually. That's sort of my 2 bullet points, isn't it? Okay, I'm going to start with alpha here. I'm just thinking about how I'm going to fit in my comparison here. So I might have to add an extra line in a moment. So let's go for beta decay. Beta decay is when a neutron turns into a proton and an electron is ejected. Okay, so what's going to happen to the atomic mass and atomic number? So atomic mass is unchanged, but atomic number increases by 1. Okay, so in both cases here, I just need to make sure the examiner knows. I know I've done 4 bullet points already, but it's that comparison part. Have I compared? Well, I think I have actually, because I've said what happens to each. I just want to make sure the examiner here knows that I know it's the atomic number that dictates that the new that a new element is created. So the type of element depends on the atomic number. So both alpha and beta create new elements. Okay, I'm absolutely making sure that the examiner knows that I know that it's the number of protons that determines what happens. I just noticed up here, actually, I've called it the proton number. When it happens, proton number drops by 2. The proton number is also, there we go, proton, atomic number. Atomic number and proton number are the same thing. One is, I think, well, yeah, one is the old specification name for it, but if you remember proton number, it's still fine. But remember, atomic number is proton number.